In this video, I'm going to show you guys how to write equations of square roots that have transformed from the parent function. So let's start with the parent function here. This is y equals the square root of x. Below this is the transformed equation. So let's look at all the different parts of the equation that we have here. If you see a negative sign in front of the equation here on the right side, that means that the graph is reflecting over the x-axis. It is flipping down. Let's talk about this a value. If the a value is greater than 1, it is going to stretch. So our graphs are going to look like this today, where they kind of shoot to the right. And a stretch would mean that it's getting taller. If a is between 0 and 1, so for example, if it's 0.25 or 0.33 or 1/8, then what it's doing, it's compressing. So if you have a graph, the parent function looks like this. A compression means it is getting flatter. It is starting to look like a straight line. All right, let's keep going here. What does the h do? Well, h is a liar. That means that whatever the value is in the house, it's going to move in the opposite direction. So for example, if I have x minus 3, that means it's actually moving to the right 3. If I had the square root of x plus 5, that means it's actually moving 5 to the left. And so h is a horizontal movement, and it is a lying number. It goes in the opposite direction that it's telling you. And then k does what k does. So whatever k is here, it's going to move up or down. Let's take a look at a couple of our examples here. Let's look at example 1. So given y equals 2 times the square root of x plus 3 minus 8, describe the transformation compared to the parent function. Okay, well, we know that the parent function is y equals the square root of x. So let's look at our components of our equation here. So we have, this is a, this is h, and this is k. Notice that in front here, where a is, right here, there is not a negative sign. That means the graph is not reflecting. But since the a value is 2, we can say, since it has an a value of 2, we can say it is stretching, or it has a stretch factor of 2. It's getting 2 times taller. Let's look at our h value. So remember, h is a liar. So that positive 3, that really means it went to the left. Let's pick another color here. It went to the left 3. So we say h equals, we'll say left 3. Let's look at the value of k. K does what k does. It's movement up or down. So since it's minus 8, that means the graph went 8 down. It went down 8. Now, if you cannot use a, h, and k, you can graph the parent function here, which I'm going to do. And then we are going to graph our transformed equation and see if these 3 conditions here are met through the transformation. So here we go. All right, so what I have here in red, this is the parent function. Parent function starts at 0, 0, or the origin. And this is our transformed equation. So you can see that the transformed equation moved to the left 1, 2, 3, and it went down 8. But how did it get 2 times taller? Let's take a look at that. Let me scroll here. We're looking at just the blue graph compared to the red graph. Don't worry about the green one here. Well, if I look at the red graph, if I go over 1 and I go up is the a value. So for the parent function y equals the square root of x, it has an a value of 1. Well, 1 times the square root of x is just simply the square root of x. So how do we know that this went 2 times taller? Well, we go over 1, and how far up you go. Notice I went up 2, so that means it had a stretch factor of 2. So I call it the over 1 up or down method. The up or down is the a value, and you can see here that this one is 2 times taller. All right, let's go back to our last example here. So now in this example, what we're going to do is we're going to take some descriptions or transformations, and we're going to piece them together and make an equation. So compared to the parent function, what is the equation of a graph that moved 8 left. Okay, so that's H is left 8. 4 down, that's my K. So down 4. It reflects, so I know I'm going to have a negative in front of the equation. That's going to be in front of the A value. And we have a compression of 1/2. So I can say that my A value is going to be negative 1/2. So now all we have to do is just piece this back into the equation that we had up top here. So we'll just fill in for A, H, and K. Don't forget about the negative. All right, here we go. So we have y equals, we'll write it down here, y equals negative, because we want it to reflect, 1/2 times the square root, and then we say x. If we want to go left 8, we want to lie, so we're going to say plus 8, right? If I go to the left of 0, those are my negative numbers. If I go to the right of 0, those are my positives. So we're lying in the house. And then simply go 4 down, so minus 4. And if you're doing multiple choice or taking a test, you could take those and plug them in. This is what it would look like here. So I have my parent function in red. This is my transformed equation. See how it's flipped upside down? That's the reflection. It went to the left 8 and down 4, but what about the 1/2? How do we calculate the 1/2? Well, we looked at that earlier. If I look at my green graph, I'm going to do the over 1 up or down method. So I go over 1, and notice I'm only going down 1/2. And since it's flipped upside down, it's negative. Thanks for watching.